thank everyone for joining this webinar. As you know from introduction, my name is Valentino. I'm a mechanical design engineer, and I have been working for Inetec R&D department about 3 years. For those of you who are yet not familiar with Inetec, we develop a robotic system for NDT, mostly for NDT inspection. We are mostly present in nuclear, but with the latest project we are stepping in medical and aeronautical industry. Except robotic system, we are also developing UT and ET probes, and also UT and ET instruments. Today, I will present you one of our robotic systems, ASPIRA robotic system, so we can get started. Now I will stop sharing my webcam so we can concentrate on a presentation. Sorry. Just for introduction, focus of this presentation is ASPIRA robotic system. Firstly, I will talk you through challenges and scope of inspection, then continue with complete system description and NDT methods used. Last but not least, you will get insights about inspection at nuclear power plant Loviisa. As you can see on presented image, here you can see ASPIRA robotic system being installed in mentioned power plant. So to ensure safety, structural integrity has to be maintained. To achieve that goal, it is necessary to evaluate material degradation. Degradation can be caused by various of reasons, such as thermal stress, mechanical radiation, and it's mostly manifested in form of cracks, hardening, and rust. To evaluate material degradation and obviously to avoid significant hazards or economic loss, NDT techniques are used. When it comes to nuclear, everything gets a bit more complicated. So different regulatory and qualification bodies prescribe a set of regulations in form of inspection codes and standards, requirements, or some other specific technical specification, which have to be met during robotic system and as well as inspection program development. And why is that important? Without a doubt, nuclear power plant safe operation is obligatory condition, and to ensure it, periodical in-service inspections are mandatory. What makes inspections successful? From my point of view, to assure fast and quality inspection, detailed inspection program has to be prepared and complete system has to be qualified. Furthermore, successful in-service inspection also means those as low as possible, as well as inspection time as short as possible. All of this finally result with cost effectiveness. It should be noted that this is exactly what robotic and automation systems enables, as exemplified by ASPIRA. So let's start with what is ASPIRA used for. Reactor vessel internals are structures located within the reactor vessel that supports and orients reactor fuel assemblies, as well as direct coolant flow through the core. The core basket, you can see a CAD model of core basket on bottom right of this slide. It's a part of internal structures which consist of vertical plates which are bolted to the edges of horizontal former plates inside the core basket. The bolts that secure the baffle plates to former plates are referred as baffle to former bolts. And that was the main goal of our inspection. So why even bother to inspect these elements? Nuclear power plants identified the cracking of baffle former bolts as early as 1988, and this problem has been occurring ever since. To tackle this issue, a ASPIRA system has been developed. ASPIRA is a multi-axis remotely operated manipulator that can access all baffle bolts and core basket inspection objects that have to be examined without any repositioning. To get better impression on core basket inspection, we will go through the scope of Loviisa inspection. The customer listed several core basket objects which are supposed to be inspected by our system, such as baffle bolts. You can see here on bottom left. Then baffle plates. We have two different types. Also some surface of interest here on top right. For example, surface around lifting holes, and for example, also with the examination of basket to shell weld, which you can see also on top right. Like I said, here on top left, we can see baffle plates, two different types. They are fixed inside the basket shelf by 312 baffle bolts arranged in four levels and 78 columns. So to be able to inspect all of these elements, let's say to cope with all listed issues, ASPIRA includes many models as presented on this slide. For example, here we can see the heart of ASPIRA control unit, which is connected to operator workstation with installed manipulator control software. Also, we can see ASPIRA robot with UT and the VT model, as well as some auxiliary systems. For example, here we have installation system, and we have also emergency removal solution. Every part of system is going to be explained separately in following slides. Yes, but what is important to say, during development process, we need to consider different aspects of robot usage, such as, for example, data acquisition. That's why we have to consider UT instruments. Also, installation. Manipulator has to be installed first safely and then quickly. Also, emergency removal. In some emergency situation, we need to have an option to extract manipulator from the inspected component. Also, in this case, high radiation had to be considered because expected radiation is from 0.4 to 100 gray per hour, which would represent really high limitation on electronic components. All these mentioned aspects result with a technical specification list. For example, one of listed specification was that the manipulator has to be able to work underwater. So to break it down in details, to explain ASPIRA robot, we have 5 degrees of freedom driven by electric motors. That would be main rotation, to be able to rotate around the core basket. Then elevation, as well as arm extraction, arm extension, arm rotation, and probe increment. We also have 4 degrees of freedom driven by pneumatics. That would be VT model extraction and rotation, probe holder extension, and also stabilizers extension and retraction. Complete manipulator is designed to work continuously underwater in a high radiation area. The manipulator is as much as 3 meters in diameter and 4 meters high. So it is really interesting that despite all of these dimensions, manipulator weighs as low as 258 kilograms. Next crucial part of ASPIRA system is control unit, which provides remote control of the manipulator, UT and VT model. It is a low voltage system. Complete system works on 48 volts of direct current. With system has pressurized air control and everything is in one box. Connection between a manipulator and control unit is provided by two cables, one for a rotation module and one for elevation module. The system is designed to be modular with possibilities for changes according to customers' requirements, of course, if any. Control box is connected to operator workstation and manipulator is driven through user interface. When we talk about user interface in Inetec, we have developed manipulator control software. Manipulator control is a software package created for control of all Inetec manipulators. The same software in different configuration can be used for driving different types of manipulators. It supports two modes of operation: the standard mode and the admin mode. The difference is that in standard mode we have safety limitations, and in admin mode, operator has to be really familiar with the equipment and also really experienced because there is all safety limitations are disabled. Typical user interface looks one developed from ASPIRA, which you can see on your screen. It consists of visualization window, access control and camera window, event log, and also every manipulator has some specific requirements, some specific windows. In this case, that would be scan plan window and pneumatic control window. All these windows can be resizable. They can be customized, dragged around screens, and closed if they are not needed anymore. So now when we are familiar with, let's say, with overall system, we might as well study UT model more closely. UT model deploys one UT probe for baffle bolt inspection, and which you can see here marked as 3, and one high radiation tolerant surveillance camera. The ASPIRA manipulator is capable to perform any required movement of the UT model and ultrasonic probe in conformity with inclination and unevenness of inspection surface. To be able to do so, UT model has arm extension, arm rotation, also probe holder extension, and probe increment. In the next two slides, I will present you how baffle bolt looks like, of course, on Loviisa example. Loviisa power plant has two types of baffle bolts. Here we can see original baffle bolt geometry. This part is baffle bolt. This is a washer. This is a former plate, and this is a baffle plate. So washer is welded to baffle bolt, and top surface is grinded, like you can see here. And this is a picture from original baffle bolt from Loviisa core basket. It is important to notice that bolt, like I said, is welded to the washer, and the top surface is grinded, so top surface of the bolt is not visible. Unlike previously mentioned geometry, replacement bolt is mechanically locked and top surface is visible. Initec probe is capable to perform ultrasonic testing on both bolt designs. So when it comes to inspection requirement, UT has to reliably detect degradation inside the bolt, and what is important to measure its size. Complete bolt has to be inspected, complete volume of the bolt, including plug belt. Detection target is flow height equal or more than 0.50 inches, which represent 30% of the bolt cross-sectional area. Here on these pictures, we can see operational cracks in head to shank region as well in threaded region. So to be able to perform inspection method has to be qualified. We received very detailed input containing objectives of qualification, inspection performance, NDT procedures, defects informations, and acceptance and rejection criteria for any defect, and so on. All these inputs had to be fulfilled to be able to qualify a method and finally to use ASPIRA. In order to qualify method, test pieces were provided by customer. Here on the top left, you can see different specimens with different defect size, which were used during qualification. Here on right, you can see calibration block for UT blind test of ASPIRA and also of Initec personnel. On pictures below, we can see already mentioned baffle bolt, and here we can see scan plan for UT of original baffle bolts. Baffle bolts were examined with ASPIRA system that employs automated remote contact ultrasonic technique from the bolt top surface in axial scan pattern, which means scan was provided by elevation and movement or was provided by probe increment. So what do inspection results look like? Image represent clearly visible baffle bolt geometry inside UT software. So if we compare image from UT software and baffle bolt geometry, we can see bottom of the head, we can see bottom of the washers, flow, and also bottom of the bolt. Here we can see some second reflections. So to understand that bit more, I will go through a few examples. So first we will start with unflowed specimen. To understand these results, you have to know that we used probe with 3 elements. That was 0, 5, and 15 degrees element. So here you can see B-scan 0 single conventional beam. And then you can see there's the B-scan in the middle. On the left, we can see 0 dual 5 degrees. And on the far right, we can see 0 dual 15 degrees conventional beam A-scan. And also on the left, we can see different C-scans. C-scans represent the area between blue and red horizontal line. So when we analyze this flow specimen, we can see that there is a bottom of the bolt head is visible here. Then we can see bottom of the washer and bottom of the bolt. There are no flows. There are no flows between. So let's go to the next example. This is 40% cross-sectional area flow in the treated region. So if we go through all 3 B scans, it is clearly visible that now we have a new indication. It's visible here, and it's also visible on all C scans. And we are able to do to perform sizing. Why sizing is important? Because with sizing you get criteria for to accept defect or maybe to change baffle bolt if needed. So you have some let's say some information that you can use like I said, in case that you have to change baffle bolt. Next specimen is 25% cross-sectional area flow in slot weld and 25% cross-sectional flow in the head to shank region. So if we look at zero single conventional beam, we can see flow in a slot weld and also flow in the head to shank region. As we can see, area for C scan is this is only a head of the baffle bolt. So here we can see flow in a slot weld. As previously mentioned, except UT, VT inspection has to be performed. Inspection imaging is carried out in almost perpendicular direction to the surface of the object. Viewing angle has to be kept in range of plus minus 60 degrees. High resolution and high radiation tolerant camera is deployed into the inspection position by VT models. So you can see VT model here. Like previously mentioned, it has possibility of extraction and rotation. We used high radiation tolerant camera from Achelberg with resolution of 720 lines. So why it's important to be able to extract or to rotate the camera? As we can see on presented picture, we have possibility of inspecting baffle place as well as bottom of surface of core basket. That was one of the listed one of the listed demands in the contract. Visual inspection of core basket object is provided by two manipulator axes, that would be rotation and elevation. Built-in pan and tilt function and powerful lights on the camera allow changing the viewing angle and lighting condition during inspection. We have produced and tested previously described system in 2018 at Initec laboratory. The whole system worked as planned. So here on the left, you can see testing of UT model on our core basket mockup. Also, if you look at this picture, it's possible to see probe used and also surveillance camera. And on right, we can see VT model and VT camera used. The whole system worked as we planned. After factory acceptance test and qualification in front of regulatory body and customers from Finland, we got a green light to move on with project to final stage and to transportation. When it comes to transportation and storage of manipulator and remote docking tool and cables, all of that is placed in one metal container. Here on right, we can see CAD plan of packing, and on left side, we can see complete system packed in a metal container, ready to be closed up and sent to Finland. To assemble and disassemble the system, only 3 people are needed without any special lifting equipment such as cranes or anything similar. So how was it to use ASPIRA? This picture on the left demonstrates, let's say both pictures demonstrates installation of ASPIRA system. If you look more closely on the left, you can see my colleague Daniel. He was a project leader and lead designer of ASPIRA robotics system. Also, you can see my colleague Ante and me installing ASPIRA robotic system in well 1 of Loviisa power plant. Installation lasted less than 1 hour. And we had no issues during installation. Once the ASPIRA was installed, we immediately started with inspection. So on top left, you can see installed ASPIRA system. Everything is underwater. And on right, you can see start of UT inspection. The whole inspection lasted less than 60 hours. In this time, we inspected all 312 bolts and all core basket objects according to contract. In overall, the entire inspection was successful regarding all requirements mentioned at the beginning. So there was no health issues, and it was fast and effective. To sum up this presentation, let me emphasize a few facts and conclusion. The development team comprised of mechanical designers, electronic designers, and software developments. During development process, team passed through all phases such as conceptual design, CAD modeling, different kind of analysis, and finally testing, production and testing. Despite all challenges, such as new requirements coming from power owners and regulators, Initec developed a lightweight modular solution for core basket inspection. In the same year, we developed, produced, tested, and successfully deployed ASPIRA system. So that would be all from this presentation. I hope you enjoyed. Thank you very much for your attention, and I would be happy to receive any feedback from you or any question if I was unclear in some area.
Yes, thank you very much, Valentino. It was a very interesting presentation. I would like to encourage now our attendees to raise a hand and put questions to Valentino. He's happy to answer all questions, even the tricky ones, I hope. So there is a little button with a hand. You can raise your hand and put the questions, either in written or I can unmute you. In the meantime, as we wait for some questions from our apparently quite shy audience, I wanted to ask you about your future plans regarding the ASPIRA. You mentioned NPP Loviisa. Are there any already contracts ahead that where the ASPIRA will be used?
We hope we'll use ASPIRA next in PWR type of power plants for inspection of core boxes. So we'll see, maybe US or some other market in the future.
Okay. You are based in Croatia, so I guess ASPIRA is also with you in Croatia. The transport costs, I was thinking if do you think of making more ASPIRA's designs to cut the cost of transport and be more visible in other parts of the world?
Can you repeat the question? Sorry.
Yes, I'm just looking if in the meantime there are any questions coming from the audience. Yes, because yeah, I was thinking you have a patent of ASPIRA. ASPIRA is
Yeah.
patented. Do you plan to design more models of ASPIRA to cut the cost of the transport for the users?
Regarding Aspira, we are using Aspira by ourselves, but we also have possibility of selling Aspira directly to customer and to provide support during inspection. So in that case, customer would be able to use Aspira system at his premises, and in case of need, Inetec experts can come and assist during the inspection.
Mm-hmm. Okay. Are there any other services as what Inetec is offering to the customers? Do you want to maybe make a little commercial
of course,
here?
yeah, of course. Except Aspira system, we have system for different elements of nuclear power plants, like we provide inspection of reactor pressure vessel, pressure vessel head, also steam generators in VVR type and VVR type. We are always open for let's say for new inspection, for new products development. So I would say we are experts in customization. So we can be really flexible and really fast. Also, as shown on Aspira system, we started from concept to successful period, from concept to successful inspection lasted less than 1 year. So
Okay. Are there any questions? Please raise your hand if you have any. I guess your presentation was very informative and all the doubts were solved from the attendees. Okay, in this case, I would like to thank you for your attention. Thank you very much, Valentino, for your interesting and important input. This is one of the webinar what we organize every month, dedicated to different subjects on technologies and innovation, research, and I would like to invite you to come to our YouTube channel of ENS to follow the records of the previous webinars, and also to follow our LinkedIn webpage and our website www.euronuclear.org, where we announce the further webinars. From my side, many thanks. Thank you for the attention, and yeah, have a nice day.
Thank you for having me, and have a nice day. Bye.
Bye bye.